Alright, this time on Captain Chaos's Laboratory, we're going to be doing another Mr. Christmas. We're going to be doing Here Comes Santa. Here it is in its packaging. I just opened it up. And it says that it hears the noise of the motor, but there's no rotation. So, let's get this thing out of its packaging. It's taped in very well. And let's see if we can find out what's going on, if the motor's bad or a bad belt or a bad gear. Maybe I should have done this before. This is the weight. This is a heavy piece of metal. So this is what weighs it down, so as it's turning it doesn't swing off its axis and tip over. Fortunately the tape took the barcode. Alrighty, so I believe this is supposed to be glued in. Almost looks like it's supposed to cam together, but I don't see any cams. It looks like it was glued. So let's get this thing on. I'm not going to stick the reindeer on it. If it's not turning, there's really no point. It won't turn with or without the reindeer if it's got a problem. It does have a nice long cord. I mean, geez, just that AC adapter has a long cord. So, plug it in. I don't know if you can hear it, but there's no motion. And that motor is just free spinning. So I'm going to remove this from the work area. And I'm going to pull up a seat. Unlike Limax, where Limax this can pop out, this is glued or epoxied in. On the bottom, I see 3 screws on the outer ring, and then down inside this hole is another screw. I'm assuming it comes apart in stages. So first thing I'm going to do is take these outer screws out. Third screw. She doesn't want to come out. Let me look under this QC pass sticker, and nope, no screw. It's either a tight fit or there's a little bit of glue on here. There we go. Ah, the screws hold the top in, not the bottom. Alright, so if you're trying to unscrew it and thinking this bottom piece comes off, you're actually just unscrewing the top. Alright, I'm going to feed some wire through so we can get this out. I want this out of my way, so I'm going to pull it down quite a bit. So, and So there's the 3 standoffs. There's a bead of glue on the inside that holds that bottom in. It's kind of odd that this hole here has a metal reinforcement in it. The other 2 don't. I'm going to say here's the problem. I have a broken piece of plastic and a broken belt. I do not know what that broken piece of plastic is for. That broken piece of plastic was in this oval hole. I don't know if it was a tensioner or if it was a spring clip for this. But that's the broken piece of plastic, because I can see the broken plastic on the edges. So this might be an easy fix, just popping on a new belt. I'm just going to check the gears, like I always do. So I'm going to slowly rotate the gears and see if I see any. Oh, nope, that gear is broke. So we got a broken gear. Still going to rotate it and check the other ones. Alright, so I'm going to put a belt on it. Let me see what I got for belts lying around. It's about the same size. Different color, but I got belts in all sorts of colors. Red, black, white, blue. This belt might be too loose. Let's find out. This belt's hard as a rock. Wow. Alright, let's turn her on and see if she rotates. She's rotating the bottom, so let me hold the bottom and do this again. Make sure my fingers are clear of all the moving gears. Now as it's going around in my hand, it's going clunk, 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 clunk as it hits that broken tooth, or that broken gear, because it opens and closes so the teeth don't mesh properly. I don't know if you can see it, but you can see the jerk maybe in the metal arm. It shudders. Alright, we'll turn the power back off. Let's open up this gearbox and see if I have a replacement gear. And this is a very quiet piece. I don't know if you could hear how quietly this was running. I'm actually pretty surprised. A lot of these pieces seem to be loud anymore. I've been looking at some of the Department 56 animated pieces recently, and a lot of those are really quiet too. I think it's just Limax that's the loudest. But I am impressed that some of these pieces use whisper quiet motors, which unfortunately they're not the easiest to find. Alright, so I took out the 4 screws, took off the cover plate. This gear looked okay in there, so I'm going to double check it now that it's out, and it is intact. I'm just going to set it in one of the standoffs, keep it up since it is covered in oil. This gear though, which is the pass-through gear that transfers the motor worm gear into the big large tooth gear up here that rotates this. This is the one that's cracked, and this is a large shaft. I don't know if you can see, this is a... See the shaft, and see if I can get this up here and compare to that shaft. That shaft's about twice as big. So that's a large shaft gear, and it is split. So let's see if I can slide it out. Apparently it slid out of the gear on the top. And the gear on the top is a cammed, or excuse me, a toothed gear hole. So some lubrication off. So the shaft has a notch in it. so the gear can only go in one way. And then this gear, it's going to be really hard to see, but right at the edge of my fingernail is a crack that goes through the teeth all the way up through the nose, which surprises me that this gear didn't slide off being broke, because it clicks, so it's opening and closing. But that hole diameter for the shaft is going to be the problem. Let's get this gear off, and then I'm going to put that in there so I don't get any of the lubrication on everything, because the lubrication's pretty clean. See what I got for gears that might work, and if I don't have any, we can do a scrape and glue, and that's where we scrape the crack and make a V-notch in it, top and bottom, and then fill that V-notch with a hard glue such as Gorilla Glue and let it bond the gear back together. I've done it before, it works pretty decently. This is a pretty fine crack. It's not abrasive and coarse. It is starting to wear the tooth where the crack is, but it's not worn badly. So. Alright. Now here comes the fun of going through these bucket of gears. Let's see if I have one that's the same size. Most likely the shaft diameter is going to be different, but I'm not too concerned about that. I can drill it out. I'm also not concerned if the nose is smooth or geared, like this one, because there's nothing for it to interfere with that I could see. My gears are either a hair too big or a hair too small. The hobby kits, they just have the generic standard sizes, which unfortunately isn't all of them. It's the right gear ratios, the teeth are correct, just the diameters. This one is extremely close, but it is off by about the width of a tooth, which would cause the gear to slip. It would just barely mesh with the gear adjacent to it and it would crack. I'm having that problem with another one I'm working on right now, another Mr. Christmas, where the gear has got a bad spot in it and it doesn't mesh and it jumps teeth and it doesn't move all the way. That one's a little harder because it uses micro gears, and micro gears are really small. They're a lot harder to find. So, ooh, how close are we on this guy? Still off by about the width of a half a tooth. It's too big, which means it would cause the gear to press out and crack. I may not have the right diameter. Actually, this one might. And just to make sure that my eyes aren't bad, I'm going to use a mic. I'm going to do it in millimeters because most gears are metric. So The OEM gear is approximately 13.86 millimeters on the flats and 13.96 on the points. And this gear is 13.84 on the flat, so it's 0.02 millimeters. So I think this one's going to work. It is, yeah, 0.02 millimeters smaller. So I might have enough teeth mesh surface area for it to grab. So let's try it. So first thing, gotta clean up the gear mess. Thought about using one of those kits that has all the little holes that have the parts organizer, but the problem with that is there's like 60 different size gears in there, and it would take me forever to go through. So this drill bit is the right size. This is the size of the shaft on the other one. So I'm going to use this drill bit to drill out this hole and make it larger, so that way it fits. You can use a power drill. I mentioned this in the past. Just be careful if it grabs, it doesn't break the gear or tear some flesh off your fingers. That's always fun. Normally when I'm doing gears, because they're plastic and nylon and other plastic type material like ABS and stuff, I usually go with a hand drill. It is slower, I understand that, but it gives you a little bit more control, and you don't have to worry about it grabbing and removing skin off your fingertips. It's just not fast. That's the downside to it. And just so you know, because like I said, that has a nose, the gear step and that nose are almost the exact same height. It might be a hundredth of a millimeter shorter, but when I had them side by side I could see that. So almost through. It's allergy season here, so sorry for the sniffling. Now, if you want to use a Dremel tool or what have you to do this, if you have a variable speed one, try and do it on low speed. So two things: you don't want it to catch and grab and then possibly break or injure yourself. Other is you don't want to get too hot and then distort the gear or weaken it. My hand drill's unscrewing. You gotta tighten it back up. There you go. I will link to this kit, even though it's not the exact gear. I know you can also try and contact Suntronics out of Florida. and see if they have the exact gear. Almost. There we go. So it's all the way through now. Now I'm just turning it to make sure I remove any burrs from the inside. Now I'm going to have to try and realign this gear that popped out. Let's see if I can do this without taking the bottom off. Line back up. Nope. She's a slippery little devil. So let me try it again. I didn't realize I could see something that might help once I get it over. I'm trying to do it from the side when I have to take it off camera for a second so I can set it below me. The top of this is clear and has a really large hole. I'll show you if I can get it, or I might be able to get this back in. There, I'm going to put my tweezers. Tweezers aren't grippy enough, so I'm going to try some thin, long needle nose. See if I can hold it in place. You might have to try and figure out how to take this apart. There's no screws that hold it on because it's on a pivot point or an axle, and it looks like it's pressed. It's actually pressed in the center right here. So it might just be one of these trial and error to try and get to it, because I don't see any way to remove the shaft that goes all the way through. It's probably hidden under something. So there's the gear, and there's the hole in the center. So now that I have the gear in my hands and I can hold it tighter, you might be able to see the cam or the notch. So now I'm going to slide her back under and try and get it to stay aligned with the hole, and then I'll try and feed it through. So there's that. And yeah. There we go. I got it. Yep. All right. So I got the gear on. Hopefully you can see it right there. I can spin it. It's pushed all the way in. So now it's time to get this all back together and then give it a test. So I'm going to wedge this up so I can press this on. You can use a screwdriver. I'm just going to use this bent piece of aluminum I use for pulling gears. And get this thing in there. You push it on a little too tight. You want some slack, meaning that you want the gear squeezed so tight that it grinds into the gearbox. So I just backed it off a little and then recentered it. And now put this guy in. Like that. It's a pretty simplistic gearbox. It only has 3 gears in it, and then there's one gear on the top that comes off, and then it has the solid gear which is mounted to the pressed shaft. So it's a pretty simplistic gearbox. If any of these gears inside the gearbox break, they're pretty standard. You may not have the smooth nose, so you might have to put a step gear in, but the step gear will not interfere for that one. The other gear next to it is a step gear, and then the other gear, which is attached to this pulley, is a worm gear, which is a standard size one too. The only one that has an oversized shaft or is different is the one I just replaced. The other ones have a standard, basically 3mm shaft or 2.8, whatever they call it. That one's more like a 4. Most hobby gears aren't that big. So, same thing as I did before, hold it from the bottom, making sure my fingers are away from the moving, spinning stuff. So, there we go. Alright, she looks good. Alright, so now let's feed this thing back together, put it on its base, and test it out under a real load where it has to move the weight of the Santa and his reindeer. So just fish the wire back through its hole. And I don't know if I mentioned it, I don't remember, but the strain relief is pretty interesting. They just use the screw and wrap the wire around it and then tighten the screw down. It's kind of strange, but it works. So she goes that way. Let's pull the wires. My fingers have that lubrication on it and they're slick. screw. Make sure they all have about the same snugness. The wire has a notch right here, so I'm going to feed the wire back through its notch, which allows you to put the base on. Here we go. Not that this does anything since it has to be glued in, but we'll center it. If this happens to you and that breaks, there's two dimples right here that if you drilled them out and put a couple of small little pointed hobby screws, they would miss the moving parts inside. You could actually just screw the base on, but you would have to constantly unglue and glue that weight on, just making sure it doesn't drop into place. It's up against the glue. Because, yeah, there's really no way to repair that plastic. So I'm going to hold this down just in case it tries to tip over. Never mind. It's just kind of lifting a little. As it rotates, this mat isn't 100% flat, but this side, so it's the counterweight side, but opposite side of the arc. But there we go. It's not making any noise. No grinding sounds, and she's working. She's just vibrating because it's wobbling. So not too horribly bad. The broken drive belt and cracked gear, which it was working with the cracked gear, but might as well fix it while we're here. And just so anybody who's wondering how I know how to put this on, there is a metal tab right here, and the inside of that has a hole. Do that. The inside of that has a hole, and that's what keeps this thing from tipping over. And this reindeer is kind of loose. Yeah, these reindeers that I'm holding on to, they're all tight. They don't rotate. So something like this, I'd either, if you wanted to, and you didn't want to use glue, you could jam like a toothpick in his butt or in his chest and break the end off and wedge it. Or a drop of glue, whether it be super glue or hot glue, just something so that the reindeer doesn't flop around. So it looks like when they clamp these together and glue them, because you can see like the seam on this reindeer is separating, it's just a press fit, and the hole that this one goes through apparently is a hair bigger because I can also move him side to side and up and down. So that's it for this one. So here comes Santa from Mr. Christmas. Broken drive belt and a cracked gear. So, and see if I can show you this fracture with a background that contrasts it. Probably not, but it's right there. Sometimes a marker will show a crack. We'll try that. It's a small crack, but it goes all the way through, and when it's under a load, it opens. So what I did is I just took the marker, just rub it on the crack, and then wipe the marker off. And the marker sticks wherever there's a seam. And run over myself. So this long line here is just a abrasive seam from it rotating, but this one that goes off towards the teeth is the crack, and it goes all the way through and all the way up the nose. It still had enough tension not to slip, but when these teeth were going around and touching the tooth from the other gear, it was doing this. And it's hard to see in the camera again because it's so small and the way my lighting is set up, that the tooth right here, the tip of it's gone, because when it opens and closes, it's not meshing with the gear next to it. So it's catching and it's wearing the tip off. So eventually this would have caused the unit to fail again. It would have either gone jerky, clicky, or it just would have, well, spun the shaft inside of that hole because there's no more tension because they're just press fit. So it would open up and it would just spin. So there we go. The little piece is repaired and ready to go back to its owner and be put back in its display when Christmas rolls around in, well, Christmas season in about 6 months. So thanks for watching. Till the next one, have a good one.